let's look at problem 3, which is some basic integrals. So if you took Math 125 last quarter, then this is very fresh. If not, then it might have been a while. So we're looking at the integral of 12x to the 5 plus 4x dx. As you know, since you've seen this before, integration is harder than differentiation because we're going backwards. Driving backwards is harder than driving forwards. Okay, so we're doing the power rule backwards. So now we're increasing the exponent by 1 and then dividing by the new exponent. So 12 divided by 6 is going to be 2. Same thing here, increase the exponent by 1, divide by the new exponent. 4 divided by 2 is 2. And then this is an indefinite integral, so there's that annoying plus c that you've got to add. That's not a simplification thing, so you probably will lose something for not doing that. Integral of e to the x, well, that's not any harder because derivative was the same thing, so integral is the same thing. All you got to do is remember to do the plus c. Okay, this is a hidden chain rule, so you could do a quick u substitution. You could write u equals 5x and figure that out, or at this point, like, it helps if you can do that u substitution in your head. So what's going to happen, cosine is the derivative of sine, first of all, so sine 5x. And what's going to happen is the opposite. If you were taking the derivative, you would gain a 5 here. So here you lose a 5, or we divide by 5. So that's 1/5. And just take a moment and check that the derivative of this gives you that back. And eventually you can be comfortable with those like little chain rules done one step. Okay, part D, we have not equals. We haven't stated what thing there is to equal yet. Okay, integral of 1 over x plus 1 over x squared dx. Okay, integral of 1 over x is natural log of x. Integral of 1 over x squared, this is x to the power of -2. So I'm increasing the exponent by 1, which is x to the power of -1, which is 1 over x, and then dividing by the new exponent. So I end up with a negative here. And there's a plus c. Oh, and I didn't add the plus c to the last one, so I lose a point for that. Be careful. Okay, part E. Okay, so this is something that you might have memorized. I do not have it memorized, so if I don't, and if it's more complicated than this, you'll have to do this anyways. I draw myself my nice little triangle. This is a plus sign, so if I put a 1 here and an x here, and to get the same answer as the rest of the world, you have to put the x on the vertical axis for some reason. And then this hypotenuse is the root of 1 plus x squared. This is trig substitution. That's how this works. And then my angle is theta. So what happens is I'm trying to create this thing by the substitution in this picture. To me, drawing the picture makes the trig substitution less arbitrary. I don't know if you'll find that, but I do. So cosine of theta is going to be pretty close to the thing I have. 1 over the root of 1 plus x squared. And then if I square both sides, I get cosine squared theta is 1 over 1 plus x squared. Okay, so that's exactly what I have. So I can substitute this with 9 cosine squared theta. It's cosine in the numerator. And then the thing I have to substitute out is dx, though. So I make the easiest expression I can with x in it, which is tan theta. Equals x. And then if I take differential of both sides, 1 over cosine squared theta, you know this is secant squared theta, but I like to write 1 over cosine squared, especially if I have cosines in the problem, because then I can replace dx with 1 over cosine squared theta d theta. The cosine squareds will cancel. So now I'm doing the integral of 9 d theta, which is just 9 theta. I'll go ahead and write my plus c here. Okay, so now I just need to put this back in terms of x. Again, I'm going to go back to my easiest version. So theta is tan inverse of x, or arctan x, depending on which notation wins out for you. We will definitely not take points off whether you choose to do one or the other. If you write arctan x, that's exactly the same thing. Okay, that's it. maybe you had, I guess the derivative of tan inverse x is 1 over 1 plus x squared. So maybe you had that memorized. If you did, you got here right away. If you didn't, now you know a way to do all of these, even if it's more complicated than this. So I claim that your time wasn't wasted watching this video. Okay, part F. Okay, here's where, yeah, right. I talked earlier about whether we should memorize the derivative of secant x. Secant inverse? Was it secant inverse? Where was it? I think it was secant. The derivative of secant was secant x tangent x. That was in my problem 1 video. You may or may not have watched that. Okay, so, right. 5 secant x tan x dx. So if you do have that memorized, then that's easy. The integral is just 5 secant x plus c. Let me take a second and see if I can derive it, just in case we can't. I won't waste too much time. If it doesn't work, it doesn't work. Oh, we can totally do this, because this is a u substitution. If I make u equal to cosine x, then du is sine x dx. Okay, don't have to have that memorized, because if you don't, you just do u substitution. That's a super nice u substitution. Okay, so then this is, oh, we would have gotten the sign wrong. I am suspicious about something. Okay, let's do this for now. So I'm going to increase the power by 1 and divide by the new power. So that's negative 5 over u plus a constant. Why is this one negative, but when I took derivative, it wasn't negative? Because this is going to be negative 5 over cosine x plus c, or negative 5 secant x plus c. Let's find out if my first video was wrong. I got a negative and a negative. Is that right? I think that's right. Negative 1 over cosine squared x times negative derivative of cosine is negative sine. Oh, this one's wrong. That's why. Okay, so here, hopefully this was useful to you. I don't know if it is in video format. I did something wrong here. I need to put a negative there in my u substitution. Okay, so then there was a negative here. That's a positive. That's a positive. I'm going to leave this video as is rather than re-recording it, because I think there's an important lesson here, which is like how to find out when you make a mistake. There's a lot of stuff in calculus, especially with signs, and I don't know, constants, and like forgetting to do chain rule sometimes, or product rule, especially when you're doing it backwards, especially when you're doing it with multiple variables, which we will be doing when we get halfway through the quarter. There's a lot of little details that you can mess up. So like having sanity checks, like, wait, I just did this problem in reverse and there wasn't a negative sign. That means one of them was wrong. So then I can go back and fix it, and now that I fixed it, I won't lose a point on my exam if this worksheet were an exam, for example. So that's how I've gone through and tried to minimize the number of mistakes I've made in calculus. Hopefully you guys come up with a system that works for you. This is one option.